Okay, I think I'm recording. Alright, so I'm going to try and keep this video short. I don't want to over-explain the robot, but I do want to get the major functions. So essentially, I'm here today to explain the robot and essentially explain how it works and how we designed it. So to start off, sorry if my voice sounds a little weird. I've been talking a lot today, so it's kind of scratchy, but essentially, a ball will start at the intake mechanism. And this arm, oh wait, let me go back to component priority. And essentially this intake arm is controlled by two pneumatic pistons. So these can either retract or extend, depending on what we want to do. And if they're extended, then it's at the correct height for us to intake a ball as these wheels spin. Once we get the ball inside of our robot, we'll have it sitting on top of this polycarbonate plate. Let me go back into part priority. So this polycarbonate plate provides their sort of floor or surface for the ball to sit on. And we also have this little wheel here just to keep the ball moving as fast as possible. And also this wheel specifically can compress, just so we can compress it against this polycarbonate plate, and keep the ball from flying anywhere we don't want it to, and just sort of keep it in place. But once we have the ball inside the robot, we have this elevator system, and essentially the ball will hit this roller first, and with these rollers spinning at opposite directions, the bands can carry the ball all the way through up to this very top portion, right where it contacts another wheel, which compresses it against this roller. Now, of course, that wheel at the top, oh, you can't see what I'm pointing. I should probably do it with the mouse. Ooh, wait, maybe this angle? Okay. So that wheel will be spinning counterclockwise, or essentially it will just be spinning at a certain direction to where the ball can be flung at a slightly upward angle to hit the shooter. Because as you'll notice, between this roller and this shooter is a bit far away, so this wheel was just added to assist the ball in hitting the shooter. And once it reaches the shooter, we have another pneumatic cylinder system, where these two cylinders, let me go back to component. Oh, that is the whole assembly. That's okay. Where these two cylinders will control the angle of the shooter and can decide exactly what angle we want to shoot the ball at. And essentially, we are planning on using these two steel wheels, which when spinning at high velocities will shoot the ball at high velocities. And of course we can adjust the angle to whatever you want. And also this little assembly in the back, this was for vision, or for just essentially trying to target the target automatically without having to, being a driver and having to manually adjust the pneumatic piston. That'll be kind of difficult. I believe these do set angles, so you could just try and line it up yourself, but this is particularly helpful if you just want to automatically have the robot lock onto a target. But once we do have it locked on, then essentially we can shoot the ball at very high velocities. Another thing to highlight are these swerve drive modules, which I don't want to go in. I'm kind of rambling for a little bit, but these are all independent of each other, which is unlike tank drive, which I won't go into. But essentially, these can all spin independently, allowing for the robot to swerve or drive in directions that normally wouldn't be capable of other types of driving mechanisms. But yeah, I wanted to keep this video short and just to highlight the essentials of our robot. And yeah, that is the CAD designed robot. Thank you for watching.